The topic for Lesson 7.5 is angles of elevation and depression. So we'll solve problems involving angles of elevation and problems involving angles of depression. How do airline pilots use angles of elevation and depression? A pilot getting ready to take off from Mount Valley Airport, she looks up at a peak of a mountain immediately in front of her. The pilot must estimate the speed needed and the angle formed by the line along the runway and a line from the plane to the peak of the mountain to clear the mountain. That is not my favorite, however, because I sure hope a pilot is doing more than estimating. I hope they're actually calculating and they know what they're doing. When we look at an angle of elevation, it is the angle between the line of sight and the horizontal when an observer is looking up. So we're looking up at the top of the cliff. At the circus, a person in the audience watches the high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 inches? Well, we have a lovely picture here to work off of, but what I'd really like to know is this total height. So 25 plus, and they went ahead on the diagram and changed 6 inches into half a foot. So 25 feet plus 5.5 feet is 30.5 feet. So that's my opposite, and I want to find adjacent to my 27-degree angle. So the ratio of opposite to adjacent is tangent. So tangent of 27 equals opposite over adjacent. My variable's in the denominator, but no worries. We can still just multiply both sides by x. I won't get a little squished. So I have x tangent of 27 equals 30.5. And I want to get x by itself, so I'm going to divide both sides by tangent of 27. So I have x equals 30.5 divided by tangent of 27. Typing that into my handy dandy calculator, I get x equals about 59.9, and we were talking about feet. Go ahead and round it to 60 feet. Sure, why not? An angle of depression is an angle between a line of sight when an observer looks down and the horizontal. A wheelchair ramp is 3 meters long and inclines at 6 degrees. Find the height of the ramp to the nearest tenth of a centimeter. All right, I will admit it, not the most practical problem either, ever, because if you knew the ramp was 3 meters long, you must have measured it, so why wouldn't you just measure the height? All right, we've said it. Okay, the directions said they wanted it to the nearest tenth of a centimeter, so I'm going to go ahead and change this length from meters to centimeters. So now I know the hypotenuse, I want to find opposite. So the ratio of opposite to hypotenuse is sine. So sine of 6 is opposite over hypotenuse. So to solve, all we have to do is multiply both sides by 300. So in your calculator, you're going to type 300 sine of 6, and it spits out the answer of about, changing it to approximately 31.4 centimeters. Vernon is on the top deck of a cruise ship, lucky him, and observes 2 dolphins following each other directly away from the ship in a straight line. Vernon's position is 154 meters above sea level, and the angles of depression to the 2 dolphins are 35 and 36 degrees. Find the distance between the dolphins to the nearest meter. Well, if we drew in 2 triangles and then found that length, that would be the distance between the dolphins. Okay, so we know, well, if that's 154, this has to be 154. So we know opposite, and we want to find adjacent. So we're going to use opposite over adjacent as tangent. So for the bigger triangle, the one with the smaller angle measure, we're going to have tangent of 35 is opposite over adjacent. So we have to multiply both sides by x to get out the denominator. And then we're going to divide by tangent of 35. So what you're going to type in your calculator is 154 divided by tangent of 35. And our calculators have a nice little fraction button. If you want to use it, you can. So the magic of the calculator says that x is about 219.93. Running to hundredths makes sense with meters. I went ahead and redrew the triangle so we could see the length of our shorter side. Not much shorter, but a little bit. Tangent is still the ratio of the side opposite to adjacent. So we're still going to multiply both sides by our variable, which this time I wrote as y. And then we're going to have to divide by tangent of 36. So we're going to type in the calculator as 154 divided by tangent of 36. And the calculator says that is about 211.96. So using the calculator and subtracting the 219.93 minus 211.96, we find out, which we wanted to know, that the dolphins are, well, if we're going to approximate, we can say about 8 meters apart. Great summary this time. Trigonometry can be used to solve problems related to angles of elevation and depression.